are you, my friends? This video is presenting 9 old exams questions related to absolute value equations and inequalities. This is related to lecture number 26 in the algebra course lectures. Find the sum of all the solutions of these equations. The first one is easy. Absolute value of 4x minus 3 is equal to absolute value of x plus 6. We know if there is an equation with two absolute values, then m is equal to n or m is equal to minus n. So this is similar to case number 1. So 4x minus 3 is equal to x plus 6, or 4x minus 3 is equal minus the whole bracket x plus 6. Simplify each equation. You get 3 minus 3 over 5. You need the sum, it will be 12 over 5. If you need the product, minus 9 over 5. Now the second one, it's clear that not arranged. We have to rearrange it. You see, we have the fractions 4, 2, and 4, so we can multiply all the equation on both sides by 4 because it's constant. So let's multiply by 4. So we get 5 minus 3 x absolute value squared, multiply by 4, so that's minus 10. This is 25 by 4 is 100. 11 over 4 multiplied by 4 is 11. And it will be this equation now. 5 minus 3x, absolute value, remember square is equal to 1, 2, 1. Take the square root of both sides. You mean take the square root like this. So 5 minus 3x plus or minus, remember, square root of 121, which is 11. So we have 1 time 11, 1 time minus 11. So the solutions are minus 2 and 16 over 3. When you add them, you get 10 over 3. Now, this one is more important, but more work than question number 1. Find the sum of all the solutions. How can you find the sum here? See, the equation is not arranged at all, but let me help you. Since we have an absolute value and we have an equal, so it looks like we have to use case number 1 of the lecture 26 because we have 3 cases, case 1, case 2, case 3. So let's cross multiply here first, rearrange, simplify the equation until you reach case number 1. Then you can apply it. That's the trick here. So we cross multiply. Oh, we have noticed here, I did not mention, absolute value of 2x minus 5, absolute value of 5 minus 2x. These are the same. We know that. Absolute value of a minus b, absolute value of b minus a. So now you can change any one to be the other. Either this one change it to this or this one change it to that. No problem. Now cross multiply here. So we have 4 times this one, 2x minus 5 minus 6 is equal to 4 minus this one. So I change it all to 2x minus 5. Take this on the other side, becomes 3. And this one, take it on this side. See, minus with the 4 here is 5. Take minus 6 on this, 4 is 10. So we have absolute value of 2x minus 5 is equal to 2. Now this is ready, lecture 26, case number 1. So we have 2x minus 5 is equal to 2, or, you have to mention or, 2x minus 5 is equal to minus 2. The first solution, 7 over 2. Second solution, 3 over 2. Figure out the numbers, please. If we need the sum, you add them. So the solution is 5. Really nice question and important. Now find the product of all the solutions. The first one is not easy actually, because we have to rearrange it. See, square root of 2, x minus square root of 8 all squared, minus 13, absolute value of 2 minus x is equal minus 6. We have to bring 6 on this side, equals 0 for sure. We have a squared here, so we have, it looks like something quadratic or quadratic in form. There is a common factor here. Let's play with this one here. Square root of 2, leave it. Square root of 8, we know 2 square root of 2. So I can take square root of 2 common, but be careful. Square root of 2 common is inside the power 2. So when you take it out, you have to square it. You see this one here? This is the whole trick. Oh, this is one of the tricks. See, square root of 8, we know 2 square root of 2. So I can write here, instead of square root of 8 is 2 square root of 2. I see there is a common factor inside the absolute value. Common factor, square root of 2, inside the absolute value. So when you take it out, don't take it square root of 2, you square it. See squared here? So it becomes 2 outside, yeah. Minus 13, absolute value 2 minus x, and then minus 6 on the other side becomes plus 6. Now again from lecture 4, we know absolute value of 2 minus x, the same as absolute value of x minus 2. So I can change both to be absolute value x minus 2. Now this is quadratic in form, so I can say let n. I change the variable to make it easy. So in the middle here, I put n, the absolute value of x minus 2. This becomes n squared. So 2n squared minus 13n plus 6. Factor it. Now to factor this, you can use slide and divide. You can go back to lectures 10, 11 for factoring, or you can use trial and error. 2x minus 1, 2n minus 1, n minus 6. If you multiply, you get this one here. So n will be half or n will be 6. Now, we need now back to x to find the values of the x. We don't need n, we need x. So remember, n is half or n is 6. Now remember, when we said let n is absolute value of x minus 2. So I put absolute value of x minus 2 is equal to half, this half here. So x minus 2, this is case number 1, plus or minus half. So there are two solutions here, 5 over 2, 3 over 2. If I take absolute value of x minus 2 is equal to 6, that's another n, x minus 2 will be plus or minus 6. So that will be 8 and minus 4. Now look at the 4 nice solutions here. 5 over 2, 3 over 2, 8 and minus 4. Multiply all this, you will get minus 120 as the product. Now, can you try please number B? A little tricky because look at number B here. Very similar. Absolute value squared, even it is arranged. Absolute value here, we have 3 minus x, x minus 3, same idea, but we have 0 here. What do? Here we have a number. It looks more difficult, but it's easier. Let me show you what to do in number B. Number B, we know that absolute value of x minus 3 is the same as absolute value of 3 minus x. So I change this one to be the same as the squared. Now we have this equation ready. Well, you can divide by 2 or you can leave it. It's up to you. Equals 0, there is no number. There is no 6, there is no 7, there is no 10 or 7 or 5 or 2 or whatever. So we can use this idea here. Suppose we have 2 t squared, see? You can also say let capital T here is equal absolute value of x minus 3. So this would be t squared. You can do that. I did not do it, but I'm reminding you, this is 2 capital T squared minus 10 capital T is equal to 0. I can take 2t inside t minus 5. This is what I did here, but I used the absolute value in the common factor. 2 outside, absolute value of x minus 3. Inside, I have absolute value x minus 3 minus 5. See, the 5 is here from there. From the 10t is 5 there. Now, this one we can divide by 2, no problem. This will not affect in the solution. That's a constant outside. So absolute value is equal to 0, or this one is equal to 5. Absolute value is equal to 0. That means only x minus 3 is equal to 0. X will be one value. This one we have positive c here, 5. So we say plus 5 or minus 5. So we have two solutions, 8 minus 2. Now all the solutions are 3 here. 3, 8, and minus 2. So the product will be minus 48. Now this one, absolute value of x minus 5 less than half is equivalent to this one here, 2x minus 3 as a compound between m and n. Find m, find n, then find m plus n. So the easy thinking here is take this one and solve it. See, it looks absolute value less than positive number. Which case you think? Not equal, there is not equal, it is not case 1, and this is less than case 2. So I just say between minus half and half. And then I have to make changes until I reach this one here. So leave this one, we need this one, leave it. This is apply directly case number 2. So x minus 5 between minus half and half. Add 5 on each side. Add 5, add 5, add 5. So 9 over 2, x between 9 over 2 and 11 over 2. Now, we need 2x minus 3. This is what we need. We know this is the solution. So let's multiply again by 2 because we need to reach there. That's the aim here. So multiply by 2 and then subtract 3. So 2x minus 3, this is what we need here. From the solution, we get 6 and 8. That's m and n. So when you add m plus n will be 14. Solve the inequality. When you have absolute value and many numbers, greater than or less than, the only thing you have to do first, rearrange it. See, multiply by the LCD, take the numbers on the other side, rearrange it until you reach either absolute value less than or absolute value greater than. So either case 2 or case 3. Let's see, the LCD is 2, so I multiply from outside. I don't touch, see, I don't touch here the expression inside. Don't touch it. So multiply by 2, multiply by 2 here, 3, multiply by 2, 7, multiply by 2, 2. Now 7 plus 2, 9, take this on the other side, divide by 4, it will be 3. Greater, see, greater now we have, okay, case 3 now. Case 3, yes. Case 3, we have to use or, remember. Or, you must say or. So this is all x, half x plus 2 over 3, less than minus 3, or this one greater than 3. So now the LCD is 6 on both in each of these inequalities. So you get x, this one, take it on the other side, minus 22 over 3. You have to go slowly in the numbers because these are easy numbers. I will not read it. I give you the idea, and x greater than 14 over 3. So remember, this is from minus infinity to minus 22 over 3, union this one to infinity. That's the solution. Solve the absolute value inequality. You can apply case number 2 because we have less than directly, but it will take time. Let's be smart here and use, you can go and see example 7 in lecture 26. Remember here, x cannot be 0 because 1 over 0 is undefined. So I can say this is absolute value of a over b, absolute value of a over absolute value of b. And then this is 1 over absolute value of x less than 5. I can take the reciprocal here because everything is positive. 1 over absolute value of x, the reciprocal, absolute value of x. 5, the reciprocal, 1 over 5. Apply case number 3. So this x will be less than minus 1 over 5 or x greater than 1 over 5. This is case number 3 here. So that's the solution. See, 0 is outside? Yes, it's outside. If it happened that 0 is somewhere here, we have to take it out. Take it out, make it open at 0. If. Now this one we have done similar in lecture 26. M is the solution of the first one. N is the solution of the second one. Find M intersection N. So we have to rearrange this and do it. Check which case, 2 or 3 for sure, because we have less than or greater than. This one, rearrange it and see the case. Okay, 2 slides for this one. Let's rearrange number 1. Rearrange number 1, multiply by 2, 6 here, 21, and then take 24 on the other side, divide by minus 6, so absolute value will be greater than, change the sign, greater than half. So look here, absolute value of x greater than or equal to half. Case number 3. So x will be less than minus half or x greater than or equal to half. That's the solution here. This is m. Now let's go to n. Rearrange it. Take 8 on the other side, minus 2, divide by minus 1. Change the sign, you have less than. Case number 2. This is case number 2, ready for you to use it. So 2x minus 1 between minus 2 and 2. Add 1, and then after that, divide by 2. You get minus half to 3 over 2. That's n. Now what do you have to do? This is the solution m, you see here. This is the solution n. You need to find the intersection of m and n on the next slide with a nice diagram. So m, let's see m here. From minus infinity until minus half. You see this is m, and also this one m here, because there are 2 parts in the m. From half until infinity, it goes to infinity. Now the n is closed from minus half to 3 over 2. Now look very carefully, because the answer is tricky. The question is normal, guys. See, have you seen something? The answer is tricky. Look at the intersection. Here the intersection, only one number. So minus half is the intersection. Also in the intersection, all this interval from half to 3 over 2. So when we say find m intersection n, this is m on the top. Below here is n. The intersection will be one number, union, another interval. In the answer, we have to put all union, 2 intervals or 3 or whatever. So here we have one number, see the set here, one number and union the interval. That's m intersection n. The answer is tricky. Now this question is tricky. Absolute value of x plus 2 something minus half equals. See, it looks equals easy, because usually when we have equal, we have case number 1. So it will be 1 solution, 2 solutions, 3 solutions, 4 solutions. It depends. But this one, it happened that the answer is interval. All right, let's see. Let's rearrange it first, please. The LCD is 6. Multiply by 6 here. 6 divided by 3, 2. So this is 4. 6 divided by 2, 3. 6 divided by 6, so 4x plus 5. Just multiply by 6. Now take 3 on the other side, becomes 8 here. Divide by 4. So what do we get here? Absolute value x plus 2 is equal to x plus 2. Special equation. You can use case 1, but we have to discuss more to get the answer. This is a special equation because it's exactly the same expression. Absolute value of x plus 2 is equal to x plus 2. So we remember this from lecture 4. Absolute value, let's say this is y is equal to y. One, this is correct only if y greater than or equal to 0. So this is like y equals x plus 2. So we say x plus 2 greater than or equal to 0. X will be greater than minus 2 or equal. So closed interval from minus 2 until infinity. That's the solution. A little tricky question. Number 9 is nice. I will show you why nice. Find the number of solutions. So when we say the number, it can be 0. Like no solution, we say the number is 0. Or 1 solution, or 2 solutions, or 3 solutions, or 4, or 5, or 6. So we have to do it because we cannot expect from the absolute value. Please here in the solution, remember that absolute value of p cubed is the same as absolute value of p all cubed, and absolute value of p squared is the same as absolute value of p all squared and outside. We have seen this in the algebra course lectures in the lecture number 4. Now, this one becomes this equation here, absolute value of p all cubed minus 7, absolute value of p all squared outside, plus 12, absolute value of p is equal to 0. Let capital Y is equal to the absolute value, not p only, the absolute value. So y cubed here, you see, minus 7y squared plus 12y is equal to 0. Take y as a common factor. Then inside we have a trinomial, easy to factor, y minus 3, y minus 4. So we have 3 y's, y equals 0, or y equals 3, or y equals 4. Back to p. Remember, we have to find p, not only y. So we go absolute value of p is equal to 0, only one solution there. Absolute, if this 0 may be 7, then we have two solutions. Absolute value of p is equal to 3, p will be plus or minus 3, case 1. Absolute value of p is equal to 4, p is equal plus or minus 4. So the solutions are 0, minus 3, 3, minus 4, and 4. Number of solutions is 5. Now, just to remind you, these are all the solutions of these questions. If you want to see, please, more examples or ideas or explanation or the formulas, please go and see the video on Algebra course, lecture 26. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I wish I can see you in another video with another topic. Thank you very much for listening. Bye.